Imagine an AI that can conjure up stunning new photos, videos, and art just from text. An AI that generates music, articles, and even entire datasets from scratch. This mind-blowing technology is called generative AI, and it's advancing rapidly. In this video, we'll demystify how generative AI works and explore its game-changing capabilities. But first, what does generative AI really mean? Put simply, it's an AI that can create new content and data algorithmically, from text to vivid imagery, natural audio, and synthetic video. Unlike AI for analysis, generative AI ideates dreams and generates brand new digital assets and works of art, as if having imagination in algorithmic form. You may have heard about some of the latest generative AI tools creating a huge buzz online, like DALL-E 2, which can generate remarkably realistic imagery from text prompts. So, when did this futuristic technology first emerge? The early foundations of generative AI go all the way back to the 1960s, with the creation of the first chatbot programs intended to hold rudimentary text conversations. However, capabilities remained limited for decades. A major breakthrough came in 2014 with the advent of generative adversarial networks, or GANs. This machine learning approach pitted neural networks against each other to generate increasingly realistic synthetic data. Suddenly, generative AI models could fabricate convincing fake images, voices, and videos. In recent years, transformer neural networks have taken generative AI to the next level. Models like GPT-3 can now write shockingly human-like text responses by analyzing massive datasets of existing writing. Truly incredible progress in just the last decade. But how do these complex AI systems actually work under the hood? Let's break it down. At a basic level, generative AI converts inputs like text or images into encoded vector representations using neural networks. This allows the relationship between data points, whether they're words, pixels, or other features, to be quantified and modeled mathematically. The AI is trained on vast datasets to learn these connections between elements, like which words tend to follow others in a sentence for natural language. Once the model develops an understanding of these relationships, it can then generate brand new data points with features that plausibly fit together, like a new coherent sentence or a realistic fake image. Advanced techniques like generative adversarial networks, or GANs, and variational autoencoders, known as VAEs, allow generative models to become remarkably adept at synthesizing creative content. They're kind of like forgers or art counterfeiters, trying to produce samples that faithfully reproduce the style and statistics of the original training data. Now, to bring this all together, how exactly would generative AI be used? Well, the applications are nearly endless. Some examples include automated conversational agents like chatbots for customer service. No need to endlessly program responses, the AI handles it. Designing fake brand spokesperson videos and deepfakes? Scary, yes, but also has uses like better dubbing for film production. Coming up with new products or industrial designs, the AI can take basic requirements and parameters and rapidly generate many options. And assisting human creators across music, writing, and visual arts with the idea generation and iteration. As you can see, generative AI opens up an incredible realm of possibility, but also controversy, which we'll dig into more soon. For now, let's recap the key points we covered in this video. Generative AI can create new content like text, images, audio, and video. Major progress came from GANs in 2014 and transformer models in recent years. These systems encode data and model relationships mathematically. Applications span creative content, chatbots, drug discovery, and much more. Now that you have the fundamentals of what generative AI is and how it works, stay tuned. Up next, we'll explore some of the pros and cons of this rapidly evolving technology, from creative potential to concerns around trust and ethics. We've only just scratched the surface so far. Now let's dive into some of the benefits this technology offers, but also the limitations and risks that come with it. First up, what are some of the potentially positive impacts of advanced generative AI systems? For starters, they can help automate manual tasks like writing repetitive content. AI copywriting tools can generate product descriptions, social media posts, and more. Generative AI also shows promise for creative fields like design, music, and architecture. It can rapidly synthesize countless combinations and variations for human creators to select from. This expands the creative process. When it comes to consuming information, generative AI offers summarization of long, complex content into easily digestible snippets. It can also translate languages while retaining an individual's voice and tone. But we have to acknowledge there are downsides too. A big one is potential inaccuracy. Generated text or audio can sound convincing, but contain false or nonsensical information. Faked imagery also raises concerns. How do we know if generative AI content is truthful or original? Right now, it's difficult to determine without meticulous human verification. More transparency is needed on the AI's data sources and decision-making. There are also unresolved questions about data bias and ethics. Does scraped training data reflect issues like racism, misinformation, or other problems in society? How might that then get amplified in AI outputs? Lots more research is required here. And furthermore, if you're interested in learning about AGI, which is even the next form of generative AI, then do watch the video on our channel explaining everything about artificial general intelligence. And now, coming back to topic, these were some pros and cons to think about when it comes to generative AI. But what were the key innovations that enabled these generative models in the first place? The transformer architecture, introduced around 2017, was truly a game changer. Unlike previous neural networks, transformers process data in parallel across massive datasets using attention mechanisms. This allowed much larger scale training of models on billions of data points, like published books and web content, and gaining a deeper understanding of patterns and relationships in language, images, video, and other data. Transformer-based models like GPT-3 astounded many AI researchers and the public with their ability to generate remarkably human-sounding text given just a sentence or two of prompt. Their creativity caught even the developers off guard. However, concerns about the ethics and risks of such powerful text generation capabilities soon arose. Issues like bias, misinformation, and plagiarism posed challenges. Some felt regulations or safeguards were needed for public release. And this brings us to the final point we'll cover today. What does the future look like for generative AI? What are some of the steps needed? While capabilities are impressive already in some areas, experts say we're still in the early stages of generative AI. In the short term, expect rapid iteration around use cases and improving the user experience. But for wide adoption, establishing trust and transparency in generative AI is critical. More rigor is needed in testing outputs for accuracy and filtering out biases or errors. Looking farther out, expect generative models to expand beyond text, images, and audio into applications like 3D and video generation, drug discovery, and even chip design. The possibilities are endless. Ensuring transparency, auditability, and truthful application of generative models will be critical as they grow more advanced. While technical safeguards can help, companies and developers must engineer AI ethically from the ground up, putting human interests first. Wielding carefully and thoughtfully, generative AI holds enormous potential to augment human creativity and problem-solving. In closing, while challenges remain, the possibilities are beyond exciting when we cover how generative AI could transform industries, automate routine work, and enhance human capabilities. But we must ensure this technology follows the path of wisdom. The future remains unwritten, as hands, both carbon and silicon, grasp the pen. Let me know your thoughts. I enjoyed exploring this fascinating topic with you all and look forward to delving into more AI themes in the future videos. Please like and subscribe if you want to stay updated on the latest developments in this fast-moving field.